Hello everyone, so today we're going to be solving a question called validate subsequence. You're given two non-empty lists of integers and you're asked to write a function that determines whether the second list is a subsequence of the first one. In this case, our second list is the sequence list and the first list is the array list. What is a subsequence? A subsequence is a set of numbers that appear in the same order but might not be next to each other in a given list. They can appear in the same order, but they do not need to be next to each other. 1 appears in the same order as 1. 6 appears next. -1 appears next. 10 appears next. This is a subsequence. But how do we know this using an algorithm? So the first thing is that we would need to check for matching elements in both lists. And to do that, we have to create a pointer variable and initialize it to 0, the start element. The next thing is that we're going to be looping on the array list, and for every matching element we encounter, pointer will increase by 1. So whenever we encounter an element, we check array index if it's equal to sequence pointer. When we check the first one, 5 is not equals to 1, so we move. We don't do anything, we move. Now 1 is equals to 1. That's good. So we found a matching element. For every time we find a matching element, pointer increases by 1. So pointer increases by 1. So pointer becomes 1. Now we move to the next thing. 22. Index has increased to 2. Index was 1 here. Index was 0 here. Now we've increased from the 0 index in sequence to the 1 index in the sequence. Index 2, is it equals to what's at index 6 in sequence? No. So we move forward again. Index 3. Is index 3 the same as what's at index 1 in the sequence list? No. We move forward again. Index 4. We compare. What is index 4? Is it equals to what is in index 1? Yes. So we increase pointer by 1 again. So pointer becomes 2. Now we move forward again. Is index 5 equals to what is at index 2? Yes. So we increase pointer by 1 again. Is index 6 equal to what's at index 3? Nope. So we don't do anything. We just move forward in the array list. Index 7 equals to what is at index 3? Yes. So we increase pointer by 1 again. So we've finished the loop on the array list. And now how do we validate using this algorithm that sequence is a subsequence of the array list? It's simple. Now we can see that the length of sequence, which is 4, so length of sequence, which is equals to 4, is equal to the pointer at the end of the loop of the array list. So if this holds true, if the length of the sequence is equal to the final value of pointer, then sequence is a subsequence of array. If it is not equal, then sequence is not a subsequence of array. Now let's go ahead and implement this using Python in a code editor. And now we have an array and a sequence. First thing we have to do to validate if the sequence is a subsequence of the array is to have a pointer initialized to the start of sequence, which is 0. Then we loop through array to check for matching elements between array and sequence. So if num is equals to sequence pointer, we increase pointer by 1. And if it's not a matching element, we simply do nothing. So at the end, we return pointer has to be equal to the length of sequence for this to be a valid subsequence. So at face value, this seems that it will work, but there's an edge case. there's a chance that pointer might go above the length of sequence, and that will be a problem because you will be accessing an index that doesn't exist. So we have to also add a check for this edge case here and say pointer has to be less than the length of sequence. This keeps pointer in the boundaries of the sequence list. And once we run, we should be getting a good result. And that's pretty much how to implement this algorithm.